Are you looking to get into OT? OT is so hot right now, but it's really hard to get the experience you need to break into the field. This combines networking, combines PLC programming. We hook it up to a human-machine interface, which is a screen that allows you to control the process. We record all this in databases that you can use for AI and analytics. And in the future, we'll keep expanding and expanding. And the best part about this project is all of this you can buy for around $400 from Automation Direct and Amazon.com. If you don't want to go through the hassle of buying all this, I sell pre-made kits, and this is just kind of to help fund the things we're doing, trying to bring these to people that don't have exposure and make events around it and make these YouTube videos and all that. So first, I also wanted to do a quick demo. Well, what are we going to be building? So what this is a PLC kit. It's a PLC with a motor controller application of some kind, whether they're running fans or pumps or whatever, industrial grinders and augers, conveyor belts, everything has a motor. So one of the most basic processes. How do you reliably and safely start and stop a motor? And you press start and the motor starts. You press stop and the motor stops. And that's it. And the reason why I chose this is because any of you can build this kit and learn how a motor controller works and how a PLC works in a weekend. This is the home page of the PLC kit, and this will be in the description of the video. And if you go here, it has all the directions, and in the wiring diagrams, I have the diagram step by step, which is what we're going to follow. This is the wiring diagram as you go step by step. And if you go in here to the BOM stands for Bill of Materials. All of this is everything you need. So you can go here and you can order all this stuff. This is the Click PLC I mentioned. Automation Direct is not really super reliable, but you could see this I/O card for $100. That's way cheaper than if you were to go Siemens or Rockwell, which is why we chose it. It's accessible. The mount we're going to build is straight off of printables. If you go to printables, this is it, and you could download all the files and print them on which is what I did. And I think it makes it really nice. Like, makes a really nice, it makes a really nice way for you to display your kit. Now, the only thing this doesn't have is the button panel. So you have this DIN rail desk mount, which you can print yourself, and then there's this button panel, which is just a 3D model I made of this thing right here. So this is going to hold 4 buttons, and it attaches. You can see it right here. It holds your buttons. Let's get started. Before I start, I'm going to take a sip of my Red Team coffee. Got to have a sip of the Red Team coffee. Let's start by building the rail itself. So we're going to build the desk mount with the DIN rail on it. So let me get out. Boom. These are the side panels. The button panel, which we'll need. The DIN rail. And our little bag of tricks. This is really cool little bag, and it has funny stickers in there and all your hardware you would need. So spill those out. Now, okay. So first thing we're going to do is attach these pieces right here, little brackets. So you take these little black screws, and we're going to screw them into this thing. Little tiny Allen head. This part's pretty fun. Oop. right, we got all the side pieces on. Now we're going to put on the DIN rail. Now, what is DIN rail? What is DIN rail? DIN rail is a standardized way of mounting things and mounting electrical stuff inside cabinets. And this is really useful because otherwise we would have to tap and screw all of our components to the back of the panel ourselves and have to fit everything together. But with this, you do this one thing, you snap this, you screw this to the back of the panel, and then you can mount all your devices, and they all fit nicely because they're all made to fit on DIN rail. And a fun fact, the DIN in DIN rail is the Deutsches Institut für Normung, and that is the German institute body that decides how we're all going to do it the same. And you know, I really appreciate the fact that they made DIN rail because I hate drilling and tapping. Hate it. All right, so to put this, you just kind of put it in here. I know Donald was saying gotta use a mallet, but that's because that was the first iteration. This one I made, when I cut it, I made it a lot better quality finish, a lot higher quality finish, so they kind of go in nicely. Look at this. This is the funnest part, I think. Just getting your hands dirty, mess with stuff. How many people on your IT team know what DIN rail is? Okay, maybe a lot of them know what DIN rail is, but that's not the point. All right, how are we going to do this one? This one may be where the mallet comes in. 1, 2, 3. Hilarious. Okay. I, 2, 3. I don't know how you say 4. I only got to 1, 2, 3. That's what everybody knows. So I could have used a rubber mallet for that, but now we have this sweet, sweet frame. How cool is that? The only thing we're missing is putting the screws that will hold the, maybe I won't put it in this one, but in the rest of them, I'm going to put the little screws that clamp the DIN rail to the bracket, and that's going to make it a lot stronger. This is the part I always skip on my own stuff just because it's strong enough. But since this is for somebody else, I'm definitely going to put it. Okay, boom. Boom. You weren't told there'd be so much screwing. Nice. One more. One more. All right, we got our little stands. What do you think? So this is the 3D printed. Oh, this is a 3D printed stand, and I really like it. So let's get to building. What next? Well, next I guess we'll just mount all these parts, and we'll go over them one by one. So the first one, of course, is the actual PLC. Let's get that bad boy out. Here is the PLC I/O card, and here is the PLC itself. Nice. New PLC box. Oh, I love it. New PLC box. Use your Weehaw screwdriver. Got to have a Weehaw screwdriver to do this kind of stuff. So I use this for everything, and I actually like them so much that I included them in the kit. So that's how much I like them. Okay, you take it out. It's got this protective stuff. Don't need no protective stuff. Now we have the PLC itself. And you can see the PLC has this open spot. So I have this PLC here. The PLC has, let me zoom in on it. It has an Ethernet port. This is a RS-232 port. And what an RS-232 port is, it's like where you would hook up to a serial device. Let's mount this baby. And as you can tell, it's designed to mount on DIN rail, as all PLCs should be designed. So this one's actually kind of cool because it just snaps like that. Instead of, a lot of them are spring loaded, so you have to pry a screwdriver in there and risk life and limb to mount this thing. This one is just snappy snap. So snap that in. Second piece is this I/O card. So I/O card, you open it up, it's got this protection to stop static electricity. Really shouldn't touch it with your hands, but I like to live dangerously. So I'm gonna put it in there. Bit tricky to get in there, but oh, that's satisfying. Do you hear that click? Then there's these clicks. Boom, now the PLC is all put together with the I/O card. This I/O card is the C08D2 6V. So I usually like the C208DR, which is relay outputs, but that was back ordered. We'll cover that later when we do the outputs and inputs. But yeah, that is the CPU. Next, we will put the circuit breaker on. Circuit breaker. Here we go. Circuit breaker. Right here. This was also an alternative that was back ordered. So, but not a big deal. It's still the same. So, what do you notice about this thing? That's right. It is also ready for DIN rail. And it's also a snap like that. Usually you have to put your screwdriver down here. So we'll see on the spring-loaded ones, you have to go like that. So I don't know if you can see there. Yeah, you pry there and it comes out. See? That's usually how you do it. So we're going to open it. We're going to mount it. Boom. Next thing is terminal blocks. Take out your big stack of terminal blocks right here. So, open this thing up. Clean up a little bit. Spill these out. This part's kind of fun. This is my favorite part. I don't know why, but putting on these terminal blocks, pretty fun, I think. I know I'm sick, but they snap in. So these are the more spring-loaded ones, which I find a little more irritating, but this is a cheap little terminal block, so I've never seen a terminal block that snaps, but yeah, this is spring. So boom, spring loaded. I'm just gonna attach all these. There's probably a faster way, but these terminal blocks, the reason why enclosures have terminal blocks is because this is a way to securely connect wires. So, for instance, if you have field wiring that goes out to your motor is probably not going to be in the enclosure itself. It's going to be out in the field somewhere. You want a way to bring in that field wiring, which is usually bigger than the control wiring inside. And so you bring in the field wiring and connect it to this terminal block on one side, and then you use another type of wire on the other side that goes inside, and it's the inside wire is nice and clean and not as rugged, and the outside wire is really rugged and thick and has shielding, and when you ship an enclosure to somebody and the construction people put it in, construction people can be pretty rough. So you want to give them a place that they could be rough and not mess your stuff up. And so you give them a terminal block, right? They can screw into the bottom of this thing and you take from the top up and make it super nice. And if they mess up a terminal block, you just replace it. And it's easy versus messing up the actual PLC or the circuit breaker, etc. So terminal blocks are used everywhere. And this is why I like this. I like what we're doing with this kit is because this is something you would really see in a factory. This is something you'd really see in a factory. This is something you will probably see in a factory if you work in OT long enough. So I just spoke to somebody at Hacken WA in Bentonville that they were putting these in their bottling lines. So pretty cool. Let me just keep doing this. Having too much fun. If you really don't like doing them one at a time, you could do the finger strength test. See how many you could do at the same time. Ah, got 4. See how many you could do, but just be careful not to break your stand. All right, so let's see what is next. Ice cube relays. So ice cube relays, let's get them. This box came apart in shipping a little bit. So ice cube relays, this is the base of the relay. And this is the part that switches. So what is a relay? This is an ice cube relay. So I'm going to put this part in there. It goes together like Legos. And this mounts. See, this one's spring loaded. So, but when you're putting it on, the spring just gets out of the way. Allows you to mount it pretty easily. So I'm going to put this on here. Goes together like Legos. All those clicks are very satisfying. Then click, satisfying. You can put these things on. I don't usually just because it's in. This is going to keep the ice cube from coming out. So let's put it on one just so you see. So that is going to keep this from coming out. See, this little clip here says, you know, that can't come out. Maybe this goes in the bottom one. Here we go. Now that is tight on there. And if I remove this, just say you remove it from there, if I remove it with the screwdriver, you can see there's a clip on it. So the solenoid won't come out. And if you can understand, this may be a safety mechanism where if this relay turns on and off your fire pump for your distribution center, and you have a huge fire and this thing has wiggled out because of vibration, the fire pump runs, it vibrates, and then comes out a little bit. Now your fire pump doesn't start anymore, and you know things are on fire. Might be good to have that protection in there, make sure that doesn't happen. So the things people think about when your life is on the line. So I'm going to just shove this in there. Go in there. There we go. Okay, and we got it on both now. So we are legit. I don't usually do that. Usually I keep them out of that. But why not do it for this? If you're going to do it right when you're trying to teach. Okay. We got our relays. What's next? Next is this fan in the button panel. So fan and button panel. So let's get our button panel. We're going to move this to the side. We're going to get our fan out. This is our fan right here. Nice, weehaw. Okay, this is going to mount like this, but we got to be careful to have this wire come out the bottom because we're going to route it over here. So we're going to have that. Let's see, this goes on top of the thing so you guys don't injure your kids' fingers. So I'm assuming you wouldn't put your finger in a moving fan, but maybe, you know what they say about assuming. So I'm going to put these screws in here. 1, 2, 3. Ooh, I thought that maybe this kit was short of screw, but no. No. Okay, then this, I made this template so it fits nicely with these. Oh, that's way nicer. Okay. You used to have to drill them out, and that's annoying. Who wants a drill? Nobody wants a drill. These conveniently fit right into the holes in the DIN rail. Sorry, I've been blocking it this whole time. You don't need the rest of that stuff, but you do need some fender washers and some nuts. So we got our 4 screws right here. We're gonna boom. Okay. Now we are going to, so we got that. Let's put on these buttons. So button, see if I got the right one. Okay. This should be either the red or the green button. Give me the button. So this button is split up into 2 parts. This part is the light. So when you turn on, see the light here? This is a light, but it's also a button. So there's the light part that we get from the PLC as an output. So this is saying it's stopped right now. And then there's the button part. When you push the button, that sends another signal to the PLC that you're pushing the button. So this part is the light part. And then there is this button that you push. And what that button does is it pushes those plungers. And those plungers push into here. And this is the button part. So this is the light part. This is the button part. And they mate together like that. And then when you push this button, it's mashing that plunger that is mashing this thing that is that is pushing the button, making the switch. So you put that together like that, and then now this red one, this red color, at least on this brand, it's probably different. This red color button means that when you have it de-energized, the button is closed, meaning electricity is allowed to flow through it. When you push the button, it pushes that plunger in and opens it. So this is what you call a normally closed contact. Under de-energized state, nobody's pushing the button. The electricity goes through. The switch is closed. You push the button and the switch opens. So if this was a light switch, the light would be on right now. You push the button and the light goes out. And actually you could see it if I zoom in on here on this PLC. Let me see if I can get it. Watch that. Let me see. Yeah, watch that little red light on the PLC, or sorry, the green light, the first green light. You can see it go out. You see that? So I'm not pushing the button, and the input is on, meaning the switch is closed. I push the button, and the switch opens, and the light goes out. Light's on when I'm not pushing. I push the button, and the light goes out. That's a normally closed contact. That's what they call that. Normally closed. So we are going to mount that. Why I keep clicking with my mouse? It's weird. We are going to mount this. We gotta loosen these screws. These screws are what hold it to the face of this is usually on the face of a panel. So you would have some kind of electrical panel or a wall or something, and you would put this, and it pinches itself between them. So this goes together like that. And now I would tighten those screws in the back and it would tighten on this thing. But we are going to add our second button first. There we go. Second button. 320224. So WeHot should pay me for the sake of doing their dirty work. So these go bye-bye. This is the same thing, okay? You got a plunger. This is pretty much the same light, but this one has a green back to it. And this green back means normally open. Normally open means right now it's open. When I push this plunger, the switch closes and that lets electricity through. So the light's out, I push it and the light will come on, and we'll see that. Actually, I'll show you on this thing real quick. So I'm going to push the start button. You see that? The light comes on. The fan starts. So when I'm not touching it, it's open. Normally open. When I push it, it's closed. Right? Makes sense. I hope. All right. And I was just screwing this little tiny screw here is what holds that back on. So now they're connected. When I push it, it's switching that switch. And then we have the light. So these are the contacts for the light. And then this is the contacts for the switch. And we'll go over all that. I'm going to loosen these things a little bit. Lots of clicks. Lots of very satisfying clicks. Okay, what else do we have? We should tighten those buttons on there. So let's tighten these buttons on here. And the way we're going to do that is by tightening these screws right here. So this screw is what holds, what clamps the button onto the panel face. All right, looks like they are pretty strong. I'm also going to tighten up my just screw in the button panel in, the nuts. Don't think you want to over tighten it. But I have had these come off, so these nuts. And that is a 11:30 seconds. Probably corresponds to something metric. 11:30 seconds. Socket. Okay. Now we have the next piece to go on, which is the panduit cover. So the panduit cover is the part that, this part here, that is going to make our wiring look really nice and professional. And this is what you would see if you opened up a factory. You'd see this, a factory controls enclosure. You'd see this, but this would be ripped off and lost somewhere long ago, which is the plight of every controls engineer, is when you go to troubleshoot and somebody's lost the panduit cover and now all the wiring is a humongous mess. But since you guys are perfect, it never happened to you. So I'm just going to screw this using and I will have one more. I'm going to screw this second screw in. There we go. Then eventually when we're done, this will go over the top and snap on. So now we have the basics put together. It's coming along nicely. So very cool. Yeah, see, that snaps on like that. Boom. Beautiful. So let's take it off for now. See, that's what people usually do, and then they whoosh, throw that away. So I think it's time for a sip of red team. What's next? Well, next you'll see these, if I bring it in closer, these jumpers right here. We're going to put these jumpers in. You see these jumpers? These jumpers pretty much join this as one common electrical point. And this is useful when you have things like, this is the negative side of the power. So you have a positive and negative side when you have a direct current, which is what we have. So we have this block that converts 120 volts AC, 120 volts in the United States, whatever you have over there, same block will work. 120 volts from the United States goes into this block, comes out as 24 volts direct current. Direct current stays the same. Instead of alternating current like that, it's direct current. So 24 volts direct current has a positive and a minus. And so this right here, this jumper set is the minus. And then you look over a little more and this jumper set is the positive. So positive, minus. So let's get to jumping. There's way more jumpers than you need in this package, but open it up. Got a little bag in here. Got a bunch of jumpers. So let's get one out. Each one of these has 10 terminals on it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll put this on the end here for the negative. And first you got to make sure, actually let's just screw it in. Let's see what happens. Okay, that one's in. So this is going to make all these the same electrical point. You know what I mean? This will be like, this is the negative power rail. You got to be careful not to tighten these too tight, because if you over torque them, they'll get nasty scarred. The head will get all beat up of the screw, and that's what happened here. You can see a couple of them are pretty gnarly looking, and we want it to look nice. We want our kit to look nice. So if you were in production, you just crank this as fast as you could. But since this is kind of our personal project, you don't have to do that. You can make it look nice. Boom. Okay. So this is negative side is done now. Now we're going to do the positive side. Stay positive, kids. So we got this 10 here. We want, if you look at this one, this has 5. We want 5. So what are we going to do? Well, what we're going to do is cut this in half. And lucky for us, it cuts really easily with a pair of strippers, which is pretty much the only other thing you'll need, except for like just regular screwdriver and the Weehaw that came with the kit, regular screwdriver. But you do need to take these screws out so you can cut it. So screw lasts forever. I'm just taking that guy out, setting him aside. And now I'm going to just take this and use the back of these wire strippers. It has a big wire cutter, and they'll slice right through this soft metal. Boom. Look at that beautiful cut. This side, sorry. Look at that cut. That's pretty good. So now we will put the screws back in. Second time. Okay. Okay, now the screws are back in. But where are we putting these? Let me show you. Hold on. How do I know where to put these? Let's share again. So if I go to my wiring diagram, I have it right here. You zoom in, you'll see 1, 2, 3, 4, 5. So you skip one and then you do the next 5. And that is what we're going to do. So skip 1, do the next 5. I'm going to put the screw back in this one. Put this back in the kit, back in the bag. The bag is closed up. You could use those for later. So where is my screwdriver? I never know where that thing is. Oh, here we go. So we are going to now screw these in. This is going to make our positive power rail or bus. So exciting. My mother told me to stay positive, and here I am. I'm a lot more negative than positive, as you can see. This twice as negative. Okay, that is complete. So now all that is left to do is wire this thing up. We have our Panduit cover. We have all the components mounted that I could see. Looking at this one, looks the same. All right, let's start wiring. So all right, so let's start wiring. If you go in your kit, you'll have these. This is 18 gauge wire. You can get cheaper wire than this, but this is 18 gauge wire, and I chose it because it's good all the way. It's a higher quality wire than the really, really cheap ones. The really cheap ones, like speaker wire, can be only good to like not so many volts. Let's see what this one is. So if you read this one, it says it's 18 gauge marine wire. So marine wire is usually more robust than regular house wire because it has to withstand the environmental conditions of being at sea. So this says here max voltage 600 volts. It is the wire is good up to 105 Celsius, which is above 200 degrees Fahrenheit. It's made out of PVC and is tinned copper, which is all good stuff. So this is a pretty good quality wire compared to some other stuff I got before. It's not so great. So I like this wire. So now I'm going to maybe move this a little back. There we go. We're going to go down to here. So the first thing we're going to do is wire up our power supply. So power supply is another part of the kit. Here you go. Power supply, you open this thing up, and it has a couple components. This part connects to your wall. This part connects to your wall. This is the block. This block right here. This is the block that converts the AC from your wall into direct current DC, the 24 volts DC. So 120 volts from the outlet goes to 24 volts DC to power your PLC. And most control system stuff is 24 volts DC power supply. But this goes up, if you can see, it goes up all the way to 240 volts AC. So if you're in Europe, you're in good shape. And the last part of the power supply is this part here. So this part is what takes your power supply and allows you to convert it to individual wires that you could then hook up to your PLC. Because if you look at your PLC power connections, they are also individual wires. So you need a way to convert from your power supply to individual wires. And that's what this is going to do. So this little tiny thing. And if you go on Amazon, this is actually meant for like LED wiring strips, like lighting. But Nobody needs to know. We're using it for education. Okay, so we are going to take this. This thing here has two terminals on it. One says positive and one says minus. So negative. We're going to take this red wire. Red is positive. So whenever you see red, traditionally, I think it's might be changing now, but traditionally red is positive. If you lift up the hood of your car, the positive terminal on your battery is usually red, and the negative terminal is usually black. So red, positive. We're going to hook up the red positive to the positive on here, and then we're going to bring it up into this terminal right here, the first terminal. So let's do that. So for that, I'll take maybe this long. Whoa, yeah, maybe this long. This should be long enough, I think. No, maybe longer. Maybe like that long. Okay, we're going to strip. Let's actually get, we're going to strip. Now when you strip wire, you just take the end of your strippers right here, and you find the gauge. I like to use one size up just because I think it's a little aggressive, but you find the gauge and you clamp down and zoink. Now when you do that, you should not see a bunch of you shouldn't see a bunch of broken strands. If you look at that, there's not a bunch of broken strands. It's still good, meaty wire, and it shouldn't be super long. Like I shouldn't strip starting down here. You'll see that a lot. Like people strip all the way down here and there's all this left over. It should be just enough to fit in the terminal, but not too long. And when you hook it up into your terminal, it should hook up nice, and you shouldn't see any exposed copper, because that's how you get shorts. So this goes up in here. And now you give it a tug test. Tug test, make sure it's tight. Millions and millions of dollars has been lost to people not giving proper tug tests to their wires. You got to tug on it. So that is that one. Now let's get this black out. So like I said, black is negative. So I'm going to unfold this and see how long I want it. So maybe we could trim it up. So I'm going to do maybe like this long and trim it up. You use more black than red. So if you're going to waste any wire, waste the black one. Use a lot more red. So now I'm going to get my strippers out and strip this. Boom. Nice. Nice strip. And this goes in the first, there we go. This goes in the first black one. First of the negative bus. So, or the negative negative. There you go. And this is where the power is going to come in. Power is going to come in right here. Actually, it got pretty close, but I'm going to trim this. I want this black one to be very similar length so that when they connect, it looks good. Got to make it look good. So this I'm going to strip. And these you definitely have to be careful to not strip too much, because this positive and negative are going to be right next to each other and very likely to short. So like we said before, this is going to go to the positive side. Let me loosen it up a little bit. Positive side has a little plus. Negative side has a little minus. So if you look at this, you'll see there's not a lot of, there's no extra hairs hanging out. There's no, it's not clamped on the insulation, but there's not a lot of extra conductor hanging out that can be easily shorted. So this, I would say, I'm pretty happy with it. Give it a little tug. This one, you need to really be careful that you're giving it a proper tug because they slip out. So at a most common, this is the most common thing to slip out. So they slip out a lot. And then that'll go under here. And we will light it up in a minute. So the next step here, we did this part, good job. One page done. The next step is to power up our PLC. So first thing we're going to do is pass through this circuit breaker. And so a circuit breaker, I added a circuit breaker. So the first people that got the kit, they didn't get a circuit breaker. But I added it just so it's easier if when we want to work on stuff, we could turn it on, turn it off. We could turn it off, work on it, change wiring, power it back on with this nice switch. It also provides some protection to the elements of your system in the case that you cross wires by accident. So I chose a 5 amp breaker. This is supposed to be a 5 amp breaker. And let me see if I chose 5 amp just because depending on who you read, usually field wiring starts at 14 gauge. So this is 18 gauge, which is a lot smaller. The higher you go, the smaller the wire. But this resource says 18 gauge should be 5 amps. So maximum 5 amps. And the circuit breaker is there to protect the wire from catching fire. So if you have more than 5 amps, it's possible that the wire is not big enough to hold all that current and it'll heat up. And the more it heats up, the more resistance it has. And that means it's harder to push electrons through. It's harder to push the electricity through. So whatever you're pushing through tries harder. And that makes the current go up, and that makes the heat go up, which makes the resistance go up, and it's a vicious cycle until something catches fire. And so this is meant to prevent that. So we're going to have this circuit breaker that says, if I see the current go above 5 amps, I'm going to trip the breaker. But there's different versions of that, and I chose in the bill of material, I chose the let me see, where is it? 5 amp. I chose this one, and this one is it's a miniature circuit breaker, and it's a B curve. And these curves, the B curve and the C curve and the A curve, these are curves that describe when the circuit breaker trips. Like for some applications, especially a motor, you need to allow some amount of inrush where when you start it, the current spikes and then it comes right back down. So some circuit breakers allow you to have that spike, and that's what the curve is. C curve allows a bigger spike than a B curve. A curve allows very little spike. So I like the B curve better for this kind of control stuff and this small motor, but they are back ordered, or they were at least. Yeah, they're back ordered till July. Not waiting till July, so I got this type C, which is just a little more forgiving and not optimal, but for our kit, it's totally not going to make a difference. So I have this. We are going to wire it up. Let me see, back to the wiring kit. We're going to wire it up to the positive. So the power came in here. We're going to take a wire and go to our circuit breaker. And then on the other side of the circuit breaker, it's going to go to our positive power rail that we just put the jumpers in for. And that's going to give power to all these. So all of our loads will come off of here. So let's do it. Whenever you switch this on and off, you'll be de-energizing this whole power rail. Kind of cool. So let's get our red out. We're going from here right to there. So don't need very long at all. Again, give it a good stripping. Strip both sides. Now, note on wire. So wire has a couple kinds. Like I said, this is marine wire before. So marine wire is especially well suited for being out in the elements, being in salt air, where you have a lot of corrosion, a lot of maybe the humidity, temperature, everything bad for a wire is on a boat. So marine wire is some of the toughest wire you can have. And another thing, one of my favorite things about marine wire is that it's stranded. So if you see, this is actually a bunch of strands, right? You see that? A bunch of strands on there. And, yeah, this is actually a bunch of strands. And what that means is that it's flexible. And when you have vibrations, oh, yeah, there you go. When you have vibrations, it doesn't break. If you take solid wire, which is the alternative and what you have in most houses, and they use it a lot on land, solid wire vibrates and then it breaks. So kind of like work hardening copper. You vibrate, you bend a paper clip, you bend it so many times and it just breaks. That's the same thing with copper, solid copper wire. But this, you could bend this a lot more. This vibrates a lot better and doesn't break. So I like stranded wire versus solid wire. And so let's connect our circuit breaker to the power. And then we'll connect it to this one. Ooh, that was a little. Again, we don't want any extra stuff hanging out because that's how you get shorts. Woo! Got to make it pretty. Okay. So there we go with that. Now we're going to come out. We just did this one. Now we're going to come out of the bottom and hook up to our power rail. And that will power all our stuff. So, but we want to go into the panduit and then come out so it looks nice. And everything, you'll see everything going into the panduit. So we want to come into the panduit cover. And then we want to come out and up into this thing. So that looks right. I hate it when I'm wrong. I might be wrong. I didn't give it too much room for forgiveness. Oop, I let my strands wander. So you don't do that. Okay. So I have connected it to this bottom here. How does it look? Looks pretty good. Then I'm going to have it come up, maybe in the same one, since it's so close. I want it round that long, maybe. Oh, you can't see. Round maybe that long, so it looks nice. Got to have it look nice. No, actually, but yeah. Doesn't really matter since it's going to be in the panduit. You can push it down or up as much as you want. Never knew you would have so much fun with a pair of strippers, did you? Boom. Okay. How does that look? Looks pretty good, I think. Give it a tug test. Give this a tug test. Give it. Oh, see? That wasn't even in there. Now, if I would have shipped it like this, it would have been a problem. So, how do we fix that? Let's get it tightened in there properly. There we go. There. Now this is usually meant for, like I said, larger wire. So this circuit breaker is meant to go into the field. It's meant for larger wire than 18 gauge. But still pretty good. Okay, now we got our power hooked up. So we got our positive rail hooked up. Now we want to connect a power cable to this 24 volts DC. And if you go over to the PLC Trainer wiring guide, you'll see, click this and go to page 22, it says, I think. Page 22, this is how you do it. So you got this thing here, which is, if you look, this thing, and it tells you how to connect it up. So we're going to have 24 volts and we're going to have 0 volts. And if you look at the bottom of the PLC, it says it on there, so to make triple sure. So 24 volts is going to go closest, and then 0 volts, and then ground. So 24 volts, it will come from the positive rail. So I'm going to all right, did a tug test, everything looks good. Going to send it over to the positive rail. And I'm going to cut it right about there so it looks nice. This wire strips really nicely. You're welcome. You're welcome. Because when you have wire that doesn't strip nicely, it's not very fun. But real. All right, we got our 24 volts wired up. Now it's time to wire our 0 volts. So 0 is going to go to the negative bus bar or negative rail. Kind of like that. So I'll cut it. It's a little long, so I'm going to trim this a little bit so you don't see any of the conductors sticking out. You don't want to see any of the conductors sticking out because that means something can slip, little stray hair comes out, which you shouldn't have any stray hairs either, but if the stray hair were to come out, it would short it. So I shortened it a little bit, and now there we go. Tug test. Tugged looked good. Gotta have everything looking good. Very important. This is electrician work, but it's controls work, and it is highly craftsman-like. So there's a craft to it, and we should observe that craft. Make it proud. So. All right, that is connected. So now we have our 24 volts and 0 volts connected. So if we connect this up, let's connect this thing up to the power. We'll turn this off and connect this up to the power. Let's see what happens. Am I going to burn the house down? Quick check. Okay, we got the positive, we got negative, negative. Got my things right over there. Okay, let's try it. 1, 2, 3. Okay, it turned on, and you got a power light on the PLC. So, perfect. This is what we wanted. Turn it off now. See how nice that is? I can go back to work now. So nice. Okay, what's next? Go back to the wiring diagram. We did all this. Keep going, and next we're going to wire up the buttons. So not the light part of the button light, but the button part of the button light. The stop button and the start button. And it looks like this C1 is going to go to the negative. So the way a button works is it needs a path from the positive to the negative. And it's going to switch on some kind of load, right? So you have a light switch on the wall, and it goes from your circuit breaker box to the light switch on the wall, to the light, back to your neutral in the circuit breaker box. So that makes a circuit. And so for the stop button starts at the positive, goes through the stop button, comes back up, and goes into C1, so this is the light switch. This is the light right here, the PLC. You press the button, and it switches this light on and off, this input, and that tells the PLC whether the button is pushed. And then this goes to the negative. So that's your circuit. And that is what you call a syncing input, right? So you have the positive here, where it goes through the switch into the input sensing on the PLC and back to the negative, and that's called a syncing input. Sourcing input would be very similar, except you're switching on the other side. And I don't like to do this because that all this has all that power on it all the time, all the way through your sensor. So it'd be like putting power to your bulb, but putting the light switch on the other side. So if somebody touches your bulb, even though the light switch is off, it would have power on it and they'd get shocked. And I don't like doing that. So I like the syncing input better, but that means I use a lot more red wires because I have a lot of this going on. It goes to the button on the red and then comes back black with nothing. So it goes to the button red, back to the PLC red, and then this is your load, and then it comes back to the negative. And we can cover inputs and outputs in more detail if that's interesting. So, and this is what I forgot on the podcast with Pascal. That was pretty funny. I started making it up. But this is what syncing and sourcing means. On an output, it's the other way around. So on the output, we'll talk about that though later. So first, let's go back. We have our syncing input. We're going to go from the positive to the switch to the PLC back to the negative. So let's go from, it goes from the positive through the switch to the PLC back to the negative. And this, whatever this is normally closed. So when you have it let go, the switch is made. So this light will be on all the time as it is on the, you saw. And then when I push this button, the light will go out. So let's wire this baby up. So we're going to take our wire and we're going to go from, what does that say? What is this one? 1, 2, 3. The third one on the power rail, we're going to go to the top terminal on the light. So we're going to go from this third one right here to the top of this red light, which is where we're burning all of our wire up, connecting these buttons. So that's about there. Cut that.
Are you in here?
Hello?
Are you in a meeting?
Not really. Recording. What's up?
I want to get the back.
Okay. Next thing we're going to do is straighten this thing out. It's kind of curvy, so I'm going to straighten this wire out. Like that to get the curve out. You don't have to do this. This is just so it doesn't look all winding. I'm going to strip it. All right, this is going to go on the third one as it shows in the wiring diagram. This is going to go, I like all the wires to go up like this so I could tie them up, make them look nice. So that's going to connect up there, you see? That's the top contact for that. So I'm going to loosen this a little bit. There we go. that goes like that onto the top. And then we're going to connect this bottom one to the PLC, right? So the top one we just connected like that. Now this bottom one is going to go to an empty spot on this terminal block, and this is where the field wiring connects into the wiring to your PLC. So we're pretending like this button's in the field somewhere. So this goes up to the first one after the positive rail. So we'll so it goes on from underneath there to maybe like that long, which is really long for this project. Running out of red. It's kind of curly. Probably why they call it a pig's tail. A pig's tail. Pig's tail. Pig's tail. It's fun to say. I hope you're having fun building this thing. It's pretty fun. So this goes like that. Now we cut off the end that doesn't have any wire on it, which is a little bit, and boom, strip. Ah. Okay, and this goes maybe right there. A lot of this is just aesthetics, so I like it better looking here. If this was production, I would just be hammering this all the way. Wouldn't care about really how it looks beyond, you want it to look reasonably good, but you can't hold the project up trying to make everything beautiful, perfect, or you will get axed. I said there'd be a lot of screwing. It's a lot of screwing. But it looks so good. I don't really like how it goes underneath this thing so much. I'm going to switch it. This is all kind of a artistic preference. Okay, and the next one is going to go from, so now we have this part wired up. We're going to go from here to 1 on the PLC. But first, let's do this C1. The black, so this is the black wire. That's going to go from C1 over to this first one here. So something like that. And this is going to go in here. And I need to find that part. Aha! It's hidden on this thing. So, boom. Got to put this in. Now, what is the purpose of this? The purpose of this is if this PLC burns up or this input-output card burns up, you need to replace it. All you got to do is disconnect this with all your wiring on it and put the new one in, and voila. Here, I'll give you a better example. So with this one over here, I don't know if you could see that. Yeah, with this one, let me see. Yeah, this one, you just disconnect this thing and boom, you replace your PLC, snap this back in, and you're good to go. And in the maintenance game, the maintenance game is all about time to get back online. So if you could disconnect this, you just disconnect this, take it off, put the new PLC in, boom, all your wiring is connected, all your field wiring is connected here. You put your PLC back in, your new one, connect these quick connector back up, and you're up and running. And that saves a ton of time, and it saves a bunch of opportunities for error. Things can be connected back up wrong. Maybe somebody gets hurt. So these quick connectors are really nice. And most PLC vendors offer some kind of quick connector for their input-output because that can be so tedious to connect up, and they want to make things fast and easy and reproducible. So PLC quick connector, very nice. So we're going to connect our first connection to this quick connector, and that seems a little long to me, but we'll see. Yeah, let's shorten it a little, maybe like that. Now this is very important for the aesthetics of the kit, this input-output card, because this is the way it's going to look. Kind of gives it a cool, when all these are connected, it's going to give it like a cool fan effect. Whoopsie. So you got to give it a tug test. Something not right. Let's tug it now. Oh yeah, that tug's a lot better. See that tug? Nice tug. Okay. Now the red will go from 1 over to where we connected the other one. So it'll go from 1 to that first one after, which is where our stop button connects. And then power will go from the positive power rail through our button up to this terminal that connects up to this terminal that goes to the first input on the PLC. And the light will light up, and that will send power back through the black cable to the negative power rail. So let's connect that wire up. This is so exciting. So this is going straight from there to there, kind of short. I think that would be long enough. Hey, that's perfect. See how that looks nice, that fan effect? Oh, I like that. I like it. So let's do this one. This is very satisfying. Oh, that looks really good. Very satisfying. So now when I turn this power on, it's a normally closed connection, so this stays closed. What do you think will happen? Is a light going to turn on, or is the light going to turn off? This light on the input here, input 1. Let's follow it. The power goes from the 24-volt power, positive, through the switch since I'm not touching it and it's normally closed. It's allowed to go through the switch when nobody's touching it. The switch is made. It goes all the way up to this terminal, up, through, into the PLC. If nobody's touching it, there'll be power here at the light. That'll make the light turn on, and the return power will go here through to the negative power rail. So I'm thinking when I turn this on, the negative power, this light here will light up. So I want to make sure you could see that light. And let's turn it on and see what happens. Or option B, will it catch on fire? Beautiful. Look, the light turned on. You see that? Light turned on there. I think you could see it. Yeah, now I'm going to push the button. Normally closed button. When I push the button, it's going to open the contact for the button, and that will remove power from the PLC input, and the light should go out. Light goes out, I release it, the light goes on. Light goes out, light is on. So now why did they make it all convoluted with this normally closed, normally open stuff? Why can't they just have it like a light switch? You push stop and the light turns on. You push start, the light turns on. Why do they have to have it different like this? The reason is, if someone were to, let's say, use a backhoe in your facility, and they were to cut this wire, right? They were to cut this wire. If it was a normally open, then when you pushed it, you'd have this. Since the wire's cut, you push the button doesn't mean anything because this is not made right here. So you're pushing stop, but nothing's happening. So imagine the motor's running, your arm's caught in it, and you're trying to stop it, and it's not stopping. So in a motor controller, almost every motor controller you'll ever see, the stop button is normally closed contact. So if anything happens, it'll just stop out of safety consideration. So see, I turned my circuit breaker off when manipulating the wiring. Good practice. Okay, boom. So I'm going to turn it back on, make sure everything still works. Yeah, I got my light. Nice. Okay, next step is the start button. And the start button is very similar. Start button goes from the positive power through the button up to the second input on the PLC and then back to the negative. They share this negative, all the inputs. Now the difference here is this green one, when you're not pushing it, it's open. When you push it, it closes, right? So when you're not pushing it, it's open. When you push it, it closes. And that's just to make sure, just like you want the stop button to function no matter what, you want the start button to function only when an operator actually wants to start the motor. So if for some reason that circuit, if for some reason somebody cut the wire, you wouldn't want the motor to start. So kind of like the opposite of stopping. You want it to stop under any condition, but you want it to start only when the operator pushes start. So that's where it's important that this contact make only when the operator pushes the button. So let's connect this up. We're going to go from the positive power rail over to the top of the start button. So I'm going to eat up all my wire. So the positive power rail all the way to my start button through the conduit. So about that. And this is where most of the wire gets eaten up, these buttons. Oh man, that was satisfying. That was really good. Oh, it's still kind of curvy though. It's annoying. Okay, let's see. So I'm going to strip this guy. Strip this guy. The most fun you can have with a pair of strippers building this kit. Remember that. Yeah, now you got to tug it. First you got to strip, then you got to tug it. This goes in here and attaches to the top of your start button. But I might have made it too long. So that attaches to the top of your start button. Now let's do the other one. Well, let's do one at a time. Let's not get ahead of ourselves, which I have a habit of doing. So that goes like that, and we are going to connect this. Now I almost clamped it on the insulation itself, which is not good because then it looks like everything's fine. You give it a tug test, everything's fine, but the wire is not actually connected. It's connected onto the insulation, and plants have had millions and millions of dollars in downtime from people doing that, so don't do that. So there it's connected to the top of the wire there, and we are going to now connect to the bottom. And just like the stop button, the bottom is going to connect up to the second one after the positive power rail and then into the PLC. So from this second one, let me make sure I'm still, the second one we're going to connect like this. Up and around to the other side of the button, which will be around there, I'd say. Ow. Don't clip your fingers, man. Don't clip your fingers. And this is kind of like, stretch it out. Oh yeah, that's satisfying. Then I'm going to strip it. I'm going to put it in there. And then this, where is it? Right here. Give it a tug test. Okay, we got our button done. That's really the hardest part is those buttons. The hardest part, I think, the whole kit. Man, that looks good. Woo! Look good. All right, let's get at the rest of this. Now we got that button in place. We got where we did this side. Now we got to do this side right here that goes up to 2. So we're going to go from the second one after the power rail to the 2 on the input output card. So real short run. But we got to make it look good. So we got that about that long. And we're going to strip the ends off. Nice stripping. Tug. Tug looks good. I cut it right there. This does not have to be perfect, but sure looks good when it's perfect. If it's going to sit on your desk and people are going to ooh and ah at it, you want it to be good. Whoops. Whoopsie, whoopsie. Okay. I twist it around so none of these little hairs get stuck. There we go. How's that look? Pretty good? Next step, let's test this thing. Oh, we did this with the power on. We are naughty. Naughty. Don't do that. So now when I press the start button, let's go back to this wire again. When I press the start button, power is going to come out of here, go to the top of my start button. This switch, when I'm not pushing it, is open. So it's not allowing current to flow through. And then it goes like this on the other side of the switch to this terminal block that goes to the number 2. So when under normal condition, like right now, it should be off, and it is. But when I push the button, then power will come through from the positive rail through the switch because I'm pushing it. Normally open means when I'm pushing it, it's closed. When I'm just not touching it at all, it's open. When I push it, it's closed. Normally open contact, it'll be closed when I'm pushing it, and it'll go back to the PLC and turn the light on. So let's see. And it does. So you have just wired up normally open and normally closed contacts into the input of a PLC. Pretty cool. All right, next is what? Next is the fan itself. So then now we're moving, we did the inputs and now we're moving to the outputs. So when you push start, that will energize the relay, which will turn on the fan. And when you push stop, that'll cut the relay out, which will cut the fan out. So we're going to wire up, it looks like we're going to wire up this output first. This C2 is going to go to So it comes from the power rail into this C2, which is a common positive for all the outputs. Then it will come out this first output and go to over here, which is kind of like the output rail I have. And it's going to go to this part of the relay. And we'll talk about the relay. And then out of the relay and over to the negative. So we'll talk about the relay. We're going to connect this positive up here to C2. And that's going to give all of our outputs power. And what these outputs are, actually, I'll explain this. What these outputs are, when I go over here, okay, what these outputs are is a relay output, which we'll talk about relays in a second, but think of it as when the condition for the output is true, it switches a switch. So you could have a pretty high load for a PLC on this switch because it's not being powered by the PLC, it's being powered from outside. And this is just a light switch. So imagine connecting a magnet to your light switch on your wall. And when you energize the magnet, it turns a light switch on the wall. So you could have 120 volts going through your wall, but it doesn't have to go through the PLC. Versus this one we got, because this one was back ordered, that actually comes out of your PLC. So you power it through the connection we're about to hook up, and then it actually sends the power through the PLC instead of just switching this switch. I like this better. It's just more robust. Of course, this is mechanical, so after a while, after a few 100,000 switches, sometimes these can stick and you need to replace them. But other than that, I like these better. They're just simpler to reason about. So let's go back to our wiring diagram and let's hook up this C2. This C2 is going to provide power to all these outputs. Let me go back up. And we are going to have this kind of out. So it goes from, it's going to be a sourcing output. It's going to go from the positive through the PLC output switch and then over to the load. So we're going to have a sourcing output, but a sinking input. But they're both very similar. Like the switching element is on the positive side, not on the negative side. So I don't know why they have to be confusing like that. But that's it. Everybody's got to be confusing. Guard your gates. So let's go back over and we're going to hook up C2 to this positive rail. C2 gets connected to the first positive rail on the top. So I'll take my red and go from first positive rail to C2, about that long. And straighten it out just a little bit. Got to turn your power off when you're working on wiring. Keep telling you that. Do better than me. Do better than me. It's going to go up here to this one. Okay. Can be a little confusing, so I'm going to strip this right here. Oh, that looks pretty. Pretty. Okay, the second one is going to go from the number 1 over to the, let's see, I have 1, 2, 3, 4, and then the fifth one. So it's going to go to the fifth one. 1, 2, 3, 4, the fifth one. So here, over to the second one, which is about there, I guess. So 1, 2, 3, 4, 5. Tug. Good tug. Way too long. Try not to cut it over your stuff because I just got little tiny shreds of wire. There we go. That looks pretty good. Could look a little tiny bit better, but come on now. It's not the Taj Mahal. So my boss used to tell me because I used to take forever to do anything. It's not the Taj Mahal. Okay. We are now going to go from the bottom of that output over to the number 8 on the relay. And if you zoom in here, this has a little coil symbol, which I don't know if I could zoom in. But yeah, it has a little coil symbol. I guess I can go to the BOM. So this is the coil symbol right here. So the coil, the relay is composed of two parts. One part is the coil. When you energize the coil, this is a better way to put it. Relay has two parts. This is the coil part. When you energize the coil becomes a magnet. Coil of wire, you energize it, it becomes an electromagnet, and it sucks down this piece of iron. And when it sucks down this piece of iron, it switches this switch. And so A contact, which is normally open, another word to say, normally open, NO, you'll see NO or A. When you energize it, the relay, it sucks down this piece of metal and it closes the switch. So under normal conditions, the switch is open, just like a button. But when you energize the relay or push the button, the switch is closed. And this is a normally closed or B-type contact. When you energize this relay, it pulls down this piece of metal and opens this contact. And so this is what this means. This is how a relay works. And so you can have on this side, this can be little PLC voltage, 24 volts, but this can be switching an enormous load on this side because the two electricities are not touching, right? So you are energizing a magnet, which is pulling in a switch, which then switches the higher power. And so you could think like when you start your car, you don't want your ignition to be directly in the line of the whole engine starting. So you have this relay. You crank the switch on your car, and this relay energizes and sucks this piece of metal down that has big contacts that close it really fast. Otherwise, our slow hands would cause enormous sparking. So you want your hand to switch, and that pulls in a magnet that's instantaneous. So that is what a relay is. And this SPST is single pole single throw. So you can have other relays that have like multiple stuff, more complicated. So maybe the relay has two different sides that energize, and depending which side energizes, uh, it does different stuff. Maybe it has multiple switches. So you could have different sides that energize into different positions, and then you could have different switches. But this is single pole, single throw. This is one, two options, either on or off, and it's only one contact. So that's single pole, single throw. So now we are going to connect. That is how a relay works, and we're going to see it in action in a second. We're going to connect this 8 and 7. It's going to go from through the PLC. It's going to energize that coil and go back to negative. So let's hook up that wire. It goes from the bottom of this one that we just connected. It's going to go from the bottom one to the number 8 on the relay. So I go like that to the number 8, which is about that long. So stick that. Oh, I stuck it in the wrong hole. Stick it in the right hole. Stick it in the right hole every time. Okay, this goes in like this, and then it's going to go to this number 8, which means I got to trim it to about there, maybe. And I'm putting it to number 8. So this one, there's a bunch of contacts on this thing. I'm doing number 8, which is the coil symbol. Forget where here we go. Number 8. Put it in right in there. So, and then the next one is going to go from number 7 to the negative. This 7 is going to go to the negative. Looks like maybe the third one over from the right. So strip. We're getting faster at this, see? Strip. And I'm going to bring it, I guess I cut it a little too long because I'm bringing it right up here to this third one. Cut it right there maybe. Boom. That looks so good. Okay, but how do we test it? Well, this is where it gets exciting. let me see if I can find a test wire. Here we go. So I have this test wire here. Let me see if I can. I got this test wire, and what I'm going to do with this test wire is I'm going to touch certain contacts, and it's going to say whether it's going to test. If I touch it with 24 volts, it should turn on. So I'm going to wire this up to the 24 volts, maybe up here. Now, this is just for demonstration purposes. You guys maybe don't want to do this because this is messing with live electricity. But 24 volts, if you're going to mess with electricity, 24 volts is pretty low voltage. So now when I turn the switch back on, this is going to have 24 volts on it because I just hooked it up to the 24 volt supply. And so I can disconnect, let's see, this output here. I'm going to disconnect the PLC output, and then I can safely test by just putting 24 volts where the PLC would have been. So let me show you on the diagram. I disconnected this wire that goes to the output where usually you would get 24 volts from, and I connected a wire to here, and I'm just going to touch there. And the relay should turn on. Actually, I could even be even safer and just screw it in. So I'm going to screw this in, and my hypothesis is that since this is tied to the positive side, the relay should energize because I have power going from this jumper here. This is disconnected. I have a wire going from here to here through the relay and back to negative. So when I turn this on, you should hear a click and that light should turn on. So let's see. Boom. You see that? That's pretty cool. So let me disconnect the CPU so I don't keep turning it on and off. See that? Hear that click? That is the relay, and you could even see it if it's close enough. You could see, let me see if I can get it close enough. There we go. Now I'm going to switch it on. You could see the little parts move inside. See that little part move? That is a switch happening. So pretty cool. That is magnetism and electricity and everything all mixed up to one. Now I have it off. I'm going to disconnect my little test jumper. But we can't test it like we did with the inputs because we have to program the outputs in the PLC. So the outputs have to be, programmed in the PLC. So the next thing I'm going to connect is I'm going to connect back up the output I had. Give it a tug. Okay, looks good. And I'm going to connect up the next wire, which is the fan itself. So I got the fan coming up here, and then I have this fan power. So from the second thing on the power rail, I'm going to connect the fan power to this top one. And if we go back, what is that top one? Let me see if I can find a top view. Is there no top view? Okay, here's the top view. This is the top of it, and this is NO. NO means what? Normally open, which means when the start button is not pushed, when the output is not on, it's open. When the output fires, then it will send electricity through here, through the coil, it will send electricity through the coil, and the coil will pull in the switch, and this will connect up. Normally open will be closed. So it'll send power through to the other side. And the other side is down here, common. So every switch has, you could think of it as, if I go back to a relay, where's the relay? Okay, here you go. if I go back to a relay, this part here is the normally open side, and this part here is the common side. And so in our case, we have both of these. This one, it has above here, it has a normally closed contact that is made, and it has a normally open. We're hooking up to this one, normally open, and then common on the other side. So one side is normally open, one side is common, whereas this would be normally closed, also hooks back up into common. So that's the way this works. So up here you have this top one is normally open, this bottom one is normally closed, the coil, and then you have common, the other side of the switch. So those are all the parts of a relay. Pretty cool. So we're going to go back to our thing here and go from the second thing on the positive power rail to the normally open contact. So I'm going to go, and this is the one that looks weird on the kit. Got to find a better way to do it that doesn't look so weird. But about that long. Strip this side, go in the second power rail. And this will make it a little shorter. Maybe that short. Perfect. This is like the perfect length, I think. All right, we got this set up. Look how nice that looks. Does that look super nice or what? Look how nice that looks. The other side is going to go. So that is that power. Now we're going to send from the common to the fan, and then from the fan back to the negative bus. So the circuit will be fan power from the positive power rail over to the normally open contact that gets pulled in and let go by the coil. So when the output fires, this switch closes and allows power to go down here. Through the fan's running and sends power back to the negative side. And that's your circuit. So let's hook up these two cables here. And these two cables here are these two tiny, tiny, tiny cables right here. So if you see these tiny cables, we are going to unfortunately cut off this beautiful quick connect. We're going to split these apart as nice as we can. One side is going to, the red side is going to go to this number 6, and the black side is going to go to the negative power rail. So we'll put the black side first. No, sorry. We will, yeah, let's put the black side first. So we got to strip this. Now I don't have a setting to strip wire this small, but I'm just going to do like this, and it just comes off. So maybe I'll do a little longer. Sometimes I like to double it up because the wire is so thin. I want to make sure it's getting a good grip. There we go. Tiny, tiny wire. So now I double it up. Now it's a little thicker. So it has the terminal has something to bite on. and we do a tug test. Now, I don't know if the terminal actually bit on the actual wire or if it bit on the insulation, push the wire out of the way since the wire is so thin. So that's going to be something we're going to have to see. And this wire will be cut like maybe right there. Oh, that worked a lot easier. I'm going to fold this in half like I did the other one. You guys even see this? Fold that in half. And this is going to go in the negative one, like 1 over. So 1 over from, oh, sorry, this is going to go in the number 6. My bad, not the negative. It's a red wire. Red wires don't go on negative. Okay. Now, when I do wiring, I like things to be like 90 degrees. I'm going to work hard to get it looking like it's 90 degrees, but it's not going to be perfect. Okay. So now that we have that in place, you know what we should do? We should reinstall our test cable and see if the fan turns on. So now the fan should turn on when this output turns on, right? Fan should turn on when the output turns on. So let's install our test cable. And this kind of testing is actually pretty common in industrial control systems because you can imagine how complex the wiring might get, and being able to unit test like you do in software or security or anything else is really important. So this is kind of like a relay power unit test. And this other side is going to go to the power rail. So now we have a jumper connected from here to here that then is going to send power through the relay coil. It's going to energize that coil, and then this fan power, this coil is energized, so normally open contact is closed because it's energized, and the fan will get power and then go back to the negative. It should turn on when I turn this switch on. Let's see what happens. Whoa! Fan turns on. Pretty cool. Okay, so now you know that your fan wiring is correct. So, and we turned our power back off when we're working on stuff. So, take those out. Hook our poor little abused output thing back out. Okay. And we are on to the lights. And the lights are really the last part, I think. Yeah, the light, and then there's this wire here. So lights are the last part of considerable investment. So the lights are going to go from, so the power flow, the flow for the lights is, it goes from the power rail to the C2 like we showed in the last one. And then the power comes out of the output and to the light and back to the negative. So super simple, just like a light switch. But the light switch is inside the PLC. The PLC decides when to turn the light on and off. So this is just like a light switch at your house, except you're using the PLC as your light switch instead of an actual light switch on your wall. So we are going to go from the 2 over here to the one after the fan coil. So do maybe like that. So then strip both sides. that side at least. You can even feel it tighten on the wire once you get a feel for it, which is always nice to get a feel for things as a craftsman. Okay, so there I have this number 2 wire, and I'm going to go to the top of the stop button. So will I have enough wire here? So I'm going, yeah, from this one. And I'm going to that terminal there, so maybe I'll make it that long. It's getting late in the video, starting to mess up. Kind of hard to get into this one, but you can do it. All right, that's the top. We're connecting the light now. So connecting this red light, this black part is holds the connections for the light itself. When you push the button, it just pushes a plunger into this part, which is the button. So now we need something to go from a black one to go from the bottom over to the negative bus bar, which is the maybe the one after, yeah, one after the PLC input. So it goes from the button, sorry, from the light over to here. See, it's about that long. You got a lot of black. this is officially the hardest one to do, these two connections. Can't see I'm connecting it to the back of this. It's hard to do without showing the camera. It's going to be even harder. All right, so that is done. Project space getting messy. Okay. Oh yeah, that's going to look good right there. Okay. You didn't know electrical people could be so vain, did you? I'm going to put that right there. Soon we'll tie wrap all these. Look really nice. So that is the stop button light. And then we'll do the start button light. Start button light goes from 3 over to there and then down to the start button. Same thing. So oh, that's going to look so good. This is for our start button. And these will all be programmed in the PLC. That looks pretty good. I could have done it a little bit. No, that looks pretty good actually. That is very satisfying actually. What do you think? Pretty satisfying. Let's see what else we got. Oh, yes, we have to come out of here into our start button. And that is the only piece we're actually lacking. Okay, I had to do another quick meeting. So we are back. We're going to test this thing. We're going to unit test the whole thing. So we should have 2 inputs and 3 outputs. Should have a start button, a stop button. You push the button, the input light should change. And get this out of the way. Go. Press this. Press this button, the start light should come on. Press this button, the stop light should go out. Press the, we're going to energize the fan motor coil like this. Whoa. We're going to energize the stop light, this, and then we're going to energize the start light like that. All right, let's do it. So I'm going to lay this very carefully. Okay. Now you should see the stop light is lit. That's input 1. I touch it, it goes out. Start light is, so when I push that, the light goes out on the input. When I push this, the light should come on the second input, and it does. Second input, the light comes on. That's the start button. This is the stop button. This is normally closed, so when I push it, the light goes out. This is normally open, so when I push it, the light comes on. Under steady state, so. Now let's test our outputs, and for that, we're going to turn this off. We're going to take out this thing. We're going to test our 3 outputs. So let's test the fan starting. Oh, I got to turn my power on. Fan starting. Fan started. Pretty cool. This will be the stop light. This will be the start light. So all 3 work. Now the only thing left to do is finish the last wire in this project. The last wire is a black wire. We're not doing this. This is the more advanced setup. If you want a more factory realistic, you'll have this that clamps to the back and it's not the power adapter. This is more robust industrial power supply. And since we got the C208D2 6V, we need to implement this common to the PLC. So then the flow of current would be from the 24-volt source into here, this V1, like we talked about, out to the button, back to 2. No, that's not correct. I'm sorry. Be out through, so be from this positive over here into V1, and then out from V1 into the button. Oh, how is it? Now I'm confused. That's it. Light, first of all. Okay, so the flow here would be from here into here, and then out from the output over to this one, through here to the light, and then back to the negative. And this serves as a common for this circuit, I guess. Doesn't make a whole lot of sense to me, but let's connect it up. So let's connect up this last wire. It's going to be so ugly. There. And we won't know if the PLC part is working until we program it, but everything else seems to work. We are done. And that is the completed kit assembly. Save that for later.